Hello all. So my vehicles are based on the understanding of human eye. So basically, whatever physiology or dynamics are seen in a human eye is being represented in both of my vehicles. So the first vehicle is based on pupil dynamics. So let's understand what the pupil is first. So in our eye, which is seen here, you have a center aperture, the black aperture, which is the pupil. So this is similar to an aperture or a lens in a camera, digital camera, but in a human eye. So this can basically increase or decrease light to allow more or less light into the eye. Okay, so this is how the light is being directed into the eye. So the pupil reacts differently to different light levels. So in a normal, regular state, this is how it is of medium size. But when you show more light into the pupil or in a very, very bright room, it's gonna constrict, it's gonna become smaller. And in a dim room, where there's very less light, it's gonna dilate or increase in size so that it can allow more light. Now we have stimuli, a cue and a response, which will be the sensors. So for the cue, we have a light source, which is the sun here. And as the sensors, we have the two pupils which are interconnected. It means that when one pupil is activated or stimulated by the light source, it is gonna activate the other sensor as well. So at a given time, both of the pupils or both of these sensors are gonna perform the same way. So we have three conditions in our stimulation. One is when the distance between the light source and the pupils is very less, or when they are at intermediate distance, or when they are too far from each other. So we have certain parameters that we can assign before running the stimulation. So we can uh, give pupil size for near, intermediate, and distance. So for near, we are going to keep it the smallest. Intermediate, we are going to let it be at 15, and then far at 25. So basically, they have to be in ascending order. So the near pupil size must be the smallest based on the physiology of a given pupil. And then we have a threshold. So with the when the pupil is within this distance from the sun, it's going to perform differently. And when it is within this distance from the sun, it's going to perform differently. So we are going to keep them at 150 and 250. You're going to see why. So now that we ran the simulation, so you have the sun, and then you have the sensors, which you can move through arrow keys. So you can see when the distance is very less, the pupils are very small. They are in constricted state. But when they have crossed the threshold of 150, you can see that they are slightly larger. They are in their intermediate state. But when they are further away, they are much larger because the distance between sun and the pupils is much larger here. So you can see that how they are reacting differently at different distances while moving around the light source. So this is the trajectory that our vehicle is taking over time while it's moving around the sun, represented in the form of Cartesian coordinates. So this is vehicle 1.